Good morning, and thank you for joining today. My name is Francois Mirand, and I am Technical Director at Future Lighting Solutions, a division of Future Electronics dedicated to solid-state lighting. Let me tell you about one of the longest-lasting series for the lighting industry. This brings us back over 10 years ago. Season 1 started October 21st, 2009, when the European Parliament released the Eco-Design Requirements for Energy-Related Products Directive. And the Season 2 continued on December 12, 2012, as the EU Commission set the Eco-Design Requirements for directional lamps, light-emitting diode lamps, and related equipments regulation. You're attending today's webcast because you do not want to wait until September 1st, 2021 to figure out what's going to happen next. I'm pleased to introduce Wouter, Director of Product Development at Lumileds, who will spoil the next episode of the saga for you. If you have any question, please log them on the Q&A and we will answer them during the call, and we'll take more at the end. Over to you, Wouter.
Thank you for the introduction, Francois, and good morning, everyone. I appreciate the opportunity to speak here to you today. It's an important topic. Most of you will probably have heard about the upcoming regulations we're going to talk about, and may to some extent already be familiar with them. So the changes that are upcoming, they've been in the works for several years, and we from Lumileds have been following them closely and helped coordinate industry inputs through Lighting Europe, which many of you may be a member of, either directly or indirectly through your national lighting associations. So we're now less than a year away from most of the changes, so the effective date of most aspects of these regulations. So it's really time now to start preparing. And as Francois said, we're going to give a bit of a spoiler. I usually think of spoiler as not a good thing when it's a movie or a book, when you want to keep the element of surprise. Here in this case, you definitely don't want to be surprised. So it's important to be prepared. So the goals for today are really to help you understand what's coming in these regulations and how they will impact your designs of lighting systems going forward. So the content for today, I've broken this webinar down in basically 3 sections. First two are the respective 2 regulations we're going to talk about, and then at the end, the third section will be about how do you implement this, how do you design lighting systems in the context of these new regulations. And then I'll stop briefly at the end of each section for clarification questions, and then we'll have more extensive Q&A time permitting at the end. I want to make 2 disclaimers before we start. First one is that this is not a comprehensive overview that I'm giving today. It's these regulations are of a very broad scope that also includes control gear. It includes a lot of lighting technologies, including non-LED. So I'm going to focus only on LED light sources, or mostly focus on LED light sources today. Second disclaimer is that, well, I've done my very best to make sure all the information in this webinar is accurate. Neither myself nor Lumileds can be liable for any errors or interpretations contained. So you should always follow the official text of the regulations, which is available at the web link included here on this slide. Okay. So before we dive in, what are the regulations that we're talking about? So the first one is Commission Regulation 2019-2020, also referred to as the Single Lighting Regulation. So this regulation contains the eco-design aspects of light sources and control gear, meaning there's functional requirements and there's power requirements. that need to be complied with. So this regulation has a very broad scope covering multiple, so basically all practical lighting technologies for illumination with a few exemptions. And it replaces a couple of existing eco-design regulations that are currently in place with a more narrow scope, for example, household lamps. So that's why it's called the single lighting regulation, because it supersedes these existing regulations. A key feature of this regulation is that light sources are now defined at a low system level. So basically, it's the smallest removable units that you have in a luminaire, for example, and we'll talk more about that later. And another key element of this regulation is that there are new obligations on replaceability of light sources in containing products, also in line with the eco-design principles. Okay, so the second regulation is the energy labeling regulation, which is basically the counterpart that has roughly the same scope, but prescribes all the information that needs to be made available for light sources and control gear. The very visible features of that will be the energy efficiency class and the energy label, which will also apply to light sources going forward. But it also defines product information that needs to be made available, and it prescribes how you should represent products in advertisements and promotional material. So there's obligations for suppliers, distributors, and online sellers in this regulation. And another central element that we'll talk about is the public online database for products, which is called EPRO. A quick look at the timeline. So as I mentioned, this has been in the works for a couple of years, and the drafting mostly took place in the 2018 time frame with public consultations, etc. And the text of the regulations was approved at the end of 2018 by the European Commission, and so 2019 was mostly some further kind of mandatory steps and legal review of the text, and so they were published in the official journal of the EU by the end of 2019. So they're officially enforced since that date. Also on that date, Lighting Europe published guidelines to help industry interpret and implement these. So I think these are very useful, and I would recommend that you take a look at those if you seek clarification or want help with how to implement these. And so while the regulations are now enforced, their effective date for most aspects is not until September 1st next year. So we're now in this implementation phase where we start preparing. One minor change, or a couple of minor changes, are being made through an omnibus amendment. So it's an amendment not only to these two regulations, but also to a couple of others. I have already included those changes, although they are not formally finalized yet. But already included them in this webinar where appropriate, because that's is the expectation that they have already been voted on. So it's the expectation that the text as it currently stands now will not change too much. So it's our best estimate of what's to come. So that's roughly the timeline we're looking at. Now, just for background, as you all know, Brexit happened in the meantime. So we, which threw a bit of a wrench in the implementation process, because now, if you want to sell products to the British market, no longer the EU rules apply, but UK product rules will apply starting January 1st, 2021. So these will, for the most extent, or for the most part, they will mirror the EU eco-design and energy labeling regulations, and the expectation is that will also apply to these new regulations. But there will be a couple of differences. So there's instead of the CE marking, there will be a UKCA marking that will need to be applied. There will not be the same database, or there will not be a separate database which is the EPREL in the EU. So there's a couple of differences. We'll probably learn more about that in the coming months. But so I just wanted to highlight that for your background, that this is also going on in the meantime. But focus for today is on the EU part. Okay, so let's get started with the first regulation, which is single lighting regulation. So the single lighting regulation, as I mentioned, covers light sources and separate control gear, also known as drivers. So I'm going to focus on light sources today, and it's important to understand the definition of a light source, as it basically determines the scope, what's in scope of these regulations. So so what is a light source? So basically the short answer is it's the smallest light emitting part that you can remove for verification. So in your classic lamp socket model, it's the lamp. It's not the luminaire. It's not the table lamp that you see depicted here. So the light source also needs to meet a couple of other criteria to be considered a light source. It needs to be able to emit white light, roughly CCT between 1940 and 12,500 Kelvin. I'll describe in more detail later. Flux density smaller than 500 lumens per square millimeter, and CRI greater than 0, and a flux between 60 and 82,000 lumens. So as you can see, this covers most practical light sources for general lighting. Now the regulation also specifies what is not a light source. So this is mostly to establish the right system level at which light sources are considered. So we say if you have a product that contains a light source that can be removed for verification, then that product is considered a containing product. So it's not a light source by itself. And so, for example, this luminaire that you see. On the other hand, if you have a light source that still contains smaller light emitting parts, but you cannot remove those parts for verification, those parts are not considered a light source. So if you have an integrated retrofit lamp, then it may still contain smaller elements that actually emit the light, but if they cannot be removed because, for example, it's been sealed or potted, then the lamp is considered a light source. And specifically for LEDs and packages, they explicitly mention them in the regulation, so they're not considered a light source. So it goes down in system level quite far, but not that far down. So if you look in practice, what is considered a light source, then in case of LED light sources, it will most typically be a PCB with LEDs mounted on it. And the packages, the LED packages themselves will not be considered a light source. So that's kind of where you draw the line usually. So as you can see, I'm also showing the chip on board package here as a light source. The regulation does not specifically mention how these are to be treated, so you can interpret them in both ways. But there is this text here that says any device intended to be used directly in an LED luminaire is not a package but a light source. And so we at Lumileds, we are preparing to qualify these chip on board LEDs as light sources, because we feel in most applications they are used directly in a luminaire and in a spotlight, for example. So we are treating them as light sources. Now, as with any regulation of this broad scope, there are exemptions, and in fact there are quite a lot for these regulations, so I'm not going to list all of them, but I'll give a few examples just to give you some some feel for what's in scope and what's not in scope. Exempt from both regulations are, for example, vehicle lighting, so cars, but also trains, airplanes, lighting. Is not in scope. Battery operated lights, for example, flashlights, torches, they're out of scope. Medical devices are also exempt. And then there are a few product types which are exempt from the eco-design requirements, so from single lighting regulation, but not from energy labeling. So these are, for example, very narrow spots, beam angle less than 10 degrees, color tunable light sources with high color purity capability. I'll talk about that more in a minute. Horticulture light sources and white light sources for entertainment lighting, for example, stage and theater lighting, where you have to meet several conditions to be in that category. So all those light sources, they don't need to meet, for example, efficiency requirements, but they do need an energy label. And so that's just to give an example. Okay, let's take a look at color light sources, because many LED light sources today have color capability. So it's important to understand how they are treated under these regulations. So if you have a fixed color light source, then it's quite straightforward. If you are within this wide range, then you're considered a light source. If you're outside this wide range with your color point, you're not in scope of the regulation. It's not a light source. However, a lot of color light sources have color tuning capability, so then it becomes a little bit more involved. So then how it works is, if you have a tuning capability or your color point can change within this wide range only, that's you're in scope. That's, for example, a CCT tunable lamp or module or dim to warm module. They're in scope and they're just considered light sources. You don't get special treatment because that's just for being able to change your color point. However, you do get some special treatment if you have a source that can be tuned both within and outside this wide range. So this is called a color tunable light source in the definitions of the regulations. And there's a power bonus associated with that, as I'll show later on. Now, if your color tunable light source can in addition be tuned to each of these color boxes, so to high purity blue, green, and red, then it is considered a high purity color tunable light source and is exempt from the single lighting regulation performance requirements, but again, not from energy labeling. And if you have a light source that can be tuned only outside the wide range, so it cannot go outside, it cannot go inside the wide range, then it's not in scope. So as you see here, that lots of LED products that we have. So you see some examples that we have. So our Luxion C color line and these modules. So a lot of these LEDs can actually reach those high purity colors, including some phosphor converted colors. So it's good to be aware of that when you're designing your system, that there's different treatment depending on what is the color point of your light source. Okay, so we've defined what light sources are. I want to talk quickly about two important concepts related to light sources in these regulations, and they're replaceability and removability. They mean different things. I'll explain that here. So replaceability is really related to the circular economy aspects of the eco-design principles. So the requirement here is that luminaires must, in principle, have replaceable light sources, unless there is a technical justification explaining why this is not possible or not appropriate. For example, this could be related to safety. But so the default is that it's required, and so you are also required to indicate whether your light source is replaceable or non-replaceable on the luminaire packaging. And this can be done by a pictogram, and some examples are provided. So pictograms have been provided here by Lighting Europe that could fulfill that requirement. So this needs to be shown on luminaires, on containing products going forward. Now this is different from removability. So removability is kind of built in the definition of a light source, because in order to be considered a light source, an element must be removable for verification. So if it's not removable, it's not a light source. So then you need to go to a higher system level. So for this, it's okay to damage the containing product if that's what it takes to remove the light source for verification, but the light source itself must not be damaged. Right, so and again, in summary, of replaceability, which is in principle required, unless there is a justification. Removability is always required, because otherwise it's not light source. Here's just a quick eye chart, which I think is helpful to visualize how you need to look at luminaires and what you need to qualify. So typically in a luminaire you will have a light source and a control gear, which is a driver. So you need to look at whether these are removable or not. So if both of them are removable, then you qualify them separately. So the light source needs to meet light source requirements, and a separate control gear needs to meet control gear requirements. If they're not removable, then you qualify the whole thing as a light source. And there's also scenarios where you can remove one of the two, so you qualify those separately, and the remaining part that cannot be removed, you qualify it in the containing product. So that's basically how it works. Okay, so that's basically all about the system hierarchy and how that all works. Now on to one of the most important aspects of this eco-design regulation, which is the power requirements. So this dictates the maximum power that is allowed in on mode for a light source. So that's P on max at a given flux, useful flux, phi use. And so the reason there's this somewhat complicated formula that has a lot of other parameters is because this regulation covers multiple lighting technologies, and the goal here of the regulator was to set a high bar for each technology relative to its own capability. And so LED light sources need to meet a relatively high standard relative to other technologies, because they want to avoid everything driving to the lowest common factor. So that's why you see this differentiation here. So the eta in here is kind of you can think of it as sort of a baseline efficiency, but then there are several modifiers here. So L is kind of the power that you're allowed at zero flux, basically. So you get some that depends on whether you have a connected or non-connected light source. F is a factor that is concerned with the with what portion of the flux you are supposed to consider. So if it's a non-directional light source, you look at all the flux. If it's a directional light source, you look only at flux in a specified cone. And then R is a factor that includes the CRI, where basically if you have a higher color fidelity, that's thought to generally to be more challenging to meet efficiently. So you're allowed a slightly higher power consumption if you have a higher color fidelity. Then the C factor also distinguishes between different light source types. So in principle it's 1, but it can be higher if your light source is directional, or if it's a mains connected light source. So it includes, compensates for some of the efficiency losses there. And if you have a color tunable light source, it's also higher. And if you have a high luminance light source, I'll talk about that in a minute, there's also a bonus for that. So you see here that as a function of flux, so you can rewrite this equation into efficiency or efficacy versus flux, and you see this kind of curves here, where at low flux, your efficacy requirement is relatively low, but then it approaches this value here, this higher value, as you go up in flux. So just to look at some examples here. So most light sources will not have an issue meeting these power requirements. But yeah, you see here there's already quite a range where you can be, and we'll talk about that more later. But yeah, so some types of light sources there will be far above. So typically low drive, mid power based modules at a neutral white CCT, they can be very high. High power, they are also still, so all of them are really in the clear here, but you see there's quite some variation as a function of okay, what type of light source are we talking about. Yeah, an important point to address here is also how do we measure the performance at what operating conditions. That's because that's also not trivial for all LED light sources. If you have a simple retrofit lamp that just, you turn it on and it has a fixed color, a fixed flux, then it's quite straightforward. That's the condition that you shall evaluate it at. But if you have a light source that's tunable, I'm showing this Philips Hue bulb here as an example, then of course there is multiple settings that you could choose, right? So the regulation says that you need to define reference control settings for these types of light sources that are basically the out-of-the-box values. So when you first install it, the setting it goes to, that's in principle, that's the reference control setting where it's also evaluated. And there's some further criteria for the reference control settings as well. Now, some modules will not be tunable, like not all have integrated controls on light sources, but be more like this, right? So it will, it's a board that's just current controlled or a COB, for example. So still in these cases, there are multiple settings possible by how you choose to drive these light sources, right? So that's mentioned here in the regulation. So if the containing product manufacturer can make choices that influence characteristics, then reference control settings need not be defined, but nominal test conditions as defined by the light source manufacturer apply. So, for example, in the case of this board, we specify it at a certain current. That's the test current. It's specified at. That's the current where the performance is evaluated. High luminance light sources, I already briefly mentioned that before. This is an important concept in especially relevant to some LED light sources, because so for some applications, mainly directional applications, high luminance light sources have a benefit because they improve optical control. So you get better, more efficient delivery of light where you want it. So it's an application benefit. But often at the source level, your source efficiency is lower because there are penalties associated with driving at high luminance. So to compensate for that, there is there's this high luminance light source definition in the regulation, and here's how that works. So, for example, if you don't have you're not considering this bonus, here is the minimum efficacy that you need to meet for a 90 CRI non-directional light source. So, for example, if you want 3000 lumen, you need to be at 106 lumen per watt. Now that can be quite challenging for some of these warmer white high CRI light sources if you drive at high luminance. So to compensate for that, there's this high luminance light source definition, which basically states that if your luminance is greater, your average luminance is greater than 30 candela per millimeter square, then you get a bonus. And so you see here this bonus. So efficacy here now is plotted versus luminance. So you can see how this works. And so I'm now looking at this fixed 3000 lumen point. And as soon as I can reach 30 candela per millimeter square, then my efficacy requirement drops, and it further and the bonus increases as your luminance increases. So what that does is it allows high luminance LEDs or modules built with these high luminance LEDs to meet the performance requirements and deliver the actual application efficiency benefits. So in this case, for example, Luxion CSP HL1. So when you drive it at its test condition of 350 milliamps, it meets this threshold, and as you drive it harder, so you could specify your module at a higher test current, it will still allow this type of module to be within the power requirements of the regulation. And you can determine this luminance by either direct luminance measurement or by intensity measurement and projected area. There's also functional requirements in the regulation. So I'll go over some of these quickly. Most of them will not be too difficult to meet. There's color rendering and color consistency requirements. There are some power quality and flicker related requirements. And then there are lumen maintenance and survival factors. So these are reliability related requirements. So related to the reliability requirements, there is a specific test defined that is a cycling test of 3600 hours that that is basically an hour and a half on, a half an hour off, 1200 times. And so that's the test that a verification authority, surveillance authority would do to verify the reliability performance. And so the requirements are that after this test, at least 9 out of the 10 samples that they take are still operational. And your lumen maintenance factor after this test must be at least what you declared it to be. So there's no absolute requirement, but you are required to declare what the performance is, and it needs to meet that value. And the maximum it can be held to is 96% after this test, which corresponds to a lifetime, so an L70 lifetime of about 26,000 hours. So if you claim a longer lifetime, yeah, the maximum it will be held to is 96%. So finally, on single lighting regulation, there's also some information requirements, which are so this responds to a lot of information that is to be printed on the or displayed on the light source itself, which is CCT and flux, and for directional light sources also beam angle. And then this is in addition to CE marking and other marking that may be required by other directives. So before I switch to energy labeling, I wanted to see if there are any quick clarification questions on this part.
Thank you, Wouter. So yeah, there are a couple of questions. Some of them you may have answered, but they may not have come very clearly. First question is, let's assume I do have a luminaire with a light source, for example, LED PCB without a control gear. I will be selling a containing product, luminaire. Am I allowed to display the energy efficiency class of the light source on the packaging of the luminaire?
Yes, yeah, and in fact there are some obligations that you have to meet as the manufacturer of a containing product. So you need to display, I believe, on your packaging, but in any case in your documentation, that your product contains a light source of energy efficiency class X, whatever it is. So yes, you are allowed, and in fact you have to do that.
Question from Angelo. Is the flux density considering the LES only or the entire surface of the PCB? I suppose he's referring to a PCB with multiple LEDs.
Right, yeah, so in that case, so this is not explicitly mentioned in the regulation, but our understanding is that it refers to discrete elements. So if you have an LED package, so multiple packages, then you look at the LES of one single element.
Okay, another anonymous question. Am I allowed to define any 27 LED bulb as a containing product which contain a LED PCB and a separate control gear inside? I guess if the light source is not removable and replaceable, the answer is no.
Right. Yeah. It's not in the spirit of the regulation, I would say. But in principle, yes. I think is nothing from preventing you from making a bulb that you can screw open and then have a replaceable light source inside that. But yeah, the goal is to have the light source be the element that you would replace if you wanted to replace the light source.
But that would be challenging to manufacture.
Exactly, yeah.
Laura is asking, presumably for LED lamp themselves, they are a product, therefore aren't a removable light source and don't have to be labeled as such. I think the answer is yes.
Sorry, could you repeat that? If you
presumably for LED lamps, I believe this is referring to LED components themselves. Right. Yeah. They are a product and therefore aren't removable light source and don't have to be labeled as such.
No, so there's labeling requirements for the light source. So and then there's also some requirements for containing products. But yeah, what's prescribed in these regulations mostly concerns the light source itself. Yeah,
and LEDs are exempt because they are considered as components.
Right. If they're
potential exception of COB LEDs that you've highlighted.
Yeah.
And then there is actually a question about the COB. when a COB is mounted onto, and it's a question from Eric, sorry, when a COB is mounted onto a fixture heatsink with a thermal interface material which actually bonds the COB permanently onto the heatsink, how to deal with the removability?
Yeah, so if it's really permanent in the sense that you cannot remove it without damaging the COB, then you would need to qualify that whole structure, so that combination as a light source, because removability is a requirement for light sources. If it is removable for verification, even though it may not be replaceable, if you have a good justification for it not being replaceable, then you could use a qualified COB and be done with it. But yeah, if it's really so permanent that you cannot remove it without damaging the COB, then you need to qualify the entire thing.
Yeah, I think this answers to a number of questions we have about less strip that are attached with adhesive tape or inserted in a deep fixture where they are not. I mean, the regulation says that it has to be disassembled, could be disassembled with common tools. Okay, so it's. Right, yeah. I think that's the answer. If it requires anything special tool or very specific process to be replaced, then it's probably not removable. Question from Oob, looking at the clock. For a tunable white lamp, is it allowed to comply to the norms for only the cold white setting and failing for the warm white setting?
Yeah, so in principle, you are, so if your cool white setting is the setting that would be your default when you turn it on for the first time, it is at full flux, and it is within the other criteria of a light source. So it is white, etc. Then yes, it is. You are required only to meet the criteria, the requirements at those settings. So then if it dims to a very warm CCT, you don't have to also meet the requirements at that very warm CCT.
Okay, well, I think that there are a couple more questions, but we will take them at the end. Thank you, Wouter. Please go ahead with the ELR.
Okay, thank you. So the energy labeling regulation defines at a high level 3 categories of information. There is information that's facing the end user or the market, basically, which is the product information sheet, which is sort of similar to the data sheet that you're all familiar with. So this is public information that helps you evaluate, compare different light sources. Then there is technical documentation, which is meant for market surveillance authorities. So this contains additional information that these authorities need to test and verify compliance. This is not public, but you're required to provide it as a light source manufacturer. And then third, there is the energy label, which is probably very familiar to everyone. This contains the energy efficiency class based on your declared performance, and this must be displayed at a point of sale and also in promotional material. Then an important element is EPREL, which is European Product Registry for energy labeling. This is a public online database where all appliances requiring an energy label must be registered, also including light sources as of starting next year. So light source suppliers must provide all or upload all the content of the product information sheet and technical documentation into this database. And then the public parts, so the product information sheet and energy label, can then also be downloaded from this database. So just a quick view of the type of information that's contained in these things. So this is the product information sheet as content as required by the energy labeling regulation. So you see that the type of information here is very similar to what you would normally see in a data sheet, right? So you see flux, you see power, CCT, CRI, dimensions, etc. Then at the technical documentation level, you see that there are some of the same elements that are required here, but there are a few additional ones. So mainly geared aimed at allowing market surveillance authorities to properly test your product. So high luminance light sources, you need to define the luminance for these high purity light sources I talked about. You need to provide excitation purity. And then in addition, you need to provide information that, further information that allows the surveillance authorities to test your products. Right? So you need to show how you have determined your energy efficiency class, what calculations you have performed, if any, test conditions, and further instructions. So that all has to be included in technical documentation, which is the non-public part. Then the energy label. So this will be familiar to all of you. And as probably most of you are aware, the scale here will change. So we will no longer have A++ and A+++ energy efficiency classes for LEDs, because right now, going forward, this will be A through G, where A will be greater than 210 lumen per watt at the mains efficacy level. So you have to apply this equation here with this factor FTM, which is kind of factors in the mains efficacy. So that means that for a non-mains light source, you would have to be close to 230 lumen per watt. So this is possible. I mean, we and other LED manufacturers have LEDs that can get there, but for most applications, that's not very practical today. So expect that you will not see a lot of Class A products on the market anytime soon. So you will see a differentiation that, depending on what type of product you have, the best you may be able to do with maybe a C or a D product or class, right? So that's so this is intended to make this future-proof for the foreseeable future, so that we have still some time to go and can improve towards Class A products. Very quickly on verification tolerances specified in the ELR. These are, by the way, also specified in single lighting regulation, so this is the same. I'm not showing this to go through each of these tolerances, but rather to draw your attention to this text here. So these tolerances are intended for verification authorities verification purposes, and they shall not be used by the supplier as an allowed tolerance to establish values in technical documentation or interpreting the values with a view to achieving compliance or communicate better performance. Right? So they're only for verification authorities. So I think this is important to keep in mind when you declare your values. They have to stand up to verification. These are the tolerances that your verification authority will use, and that's it. So this is done because this makes things much easier to enforce. So to remove any element of unclarity or discussion about that, this is specified here. So that was what I had on the energy labeling section. Any questions on this before we go to the last part?
Yes, actually, questions that people want some clarification. So, first question from an anonymous attendee: do the same regulations apply to portable lighting as well as fixed permanent mains lighting? I think portable lighting you answered already in the beginning. Yeah. It's no, it's exempt. Fixed permanent mains lighting, I'm not sure what it means, to be honest. Okay, so
yeah, I'm not exactly sure of the question, but if it's fixed mains lighting, then it sounds like it's not battery powered, so that's not a reason for it to be exempted. There might be other reasons why a certain application might be exempt. But, yeah, principle is in scope.
Chris is asking, I think he's referring to the on and off cycle test. Does this mean 6-month test per lamp?
Yes, 3,600 hours. That's roughly 5 months. Yeah, including all setup, and so yeah, you're pretty much looking at half a year. So this is what the surveillance authorities will do when they verify your product. They verify your light source. It doesn't mean that as a light source supplier, you need to do this test for every product or have it done by a third-party lab for every product. You just need to declare the value that it will that you certify that your product will stand up to when being verified, right? So that's but yeah, it is quite a long test.
Yeah, a question that comes up quite frequently is, and this one is worded this way: what has a LED PCB, so an LED module as a light source, to fulfill in regard of flicker, endurance test, etc.? Because most of the parameters depends on the driver within the containing product, and also depend on the heatsink of the containing product.
Correct. Yes. So for regarding flicker, so this is only for mains connected light sources where these are specified, right? So which I guess makes sense, because if you have that's where you start running into these issues. So you have a this short-term flicker metric, this PST, needs to be smaller than 1 at full load, and the SVM needs to be smaller than 0.9. This is, by the way, per the amendment. And then starting 2024, it needs to be smaller than 0.4. So this is stroboscopic effects. But again, this is only for mains connected light sources.
So typically retrofit bulbs, for example.
Yeah.
And I think this is the rest of the question is pretty common. When you have an LED module, an LED PCB, well, the definition is generally it has to be DC powered, right? And also when you have an LED PCB, it will come with a nominal operating current and operating temperature, like the TC point. So this is where this module will have to fulfill the requirements. I think you mentioned at some point that if the light module light source is used at a different regime from what is specified by the light source manufacturer, then you have to apply different ways.
Yeah. Well, yeah. So you qual the condition at which it is qualified by the or at which it is tested and specified by the light source manufacturer are the conditions that apply when a light source is being tested.
And question from Gear, as I understand, the SLR, the requirements for the PSTLM and the SVM is only for main supply light source and not for containing product. I think you answered that questions.
Yes.
Just now, just before. With regards to, and Gianluca is asking, with regards to FAQs, when there are removable optic elements, for example, diffuser, lens, reflector, which flux should I consider? And second part of the question, when the lens is mounted on LED modules, can be considered an integral part of the LED module?
Yeah, that's a good question. So there's definitely, when you have optics that are involved, are they part of the light source or not? And again, I think it depends on whether they are removable. I guess you could state in your technical documentation, like, what is the light source that you are declaring, right? So it's so that could include optics if appropriate. But yeah, in principle, if nothing else is specified, you'll go down to the lowest system level, so that's without optics. And okay. Yeah, so you will have to declare accordingly to how you want your light source to be considered.
Question from Jonas. How is the power peon measured in case of a smart lamp containing control gear? For example, this consumes power when the bulb is off. Does it include the power of the for the communication part of the connectivity part itself?
Yes, so all power that's needed for controlling the light is included. So I think there is a clause that says the non-lighting related parts, if you have any. So in a product that maybe in a containing product that does not only lighting but also other things, you don't include that power, but anything that's so control related. So for maintaining reference control settings, for example, that is included. Yeah. And that's also why for a connected light source, for example, you have a higher allowed power than for a non-connected light source.
Yeah, you have a higher standard power allowed. Yeah. Question from Dave. How does the regulation define whether a light source is directional or non-directional?
Directional means that you have more than 80% of flux contained in a cone of 120 degrees. So it's pi steradian. So that's a little more than Lambertian, just for reference. A little more directional than Lambertian.
Okay. Okay, so Kevin is asking, if I supply a project-specific bespoke luminaire containing a bespoke LED light source, does all the information have to be listed on the public database?
Yes, our understanding is that yes, also in the case of bespoke or custom light sources, that applies. Yeah, because it's still placed on the EU market, and therefore the regulations apply.
And well, if you specify that the light source is not removable, then you don't need to provide the details for the light source itself.
Right, but then you will need to qualify your whole product as a light source.
Exactly. Then you have to qualify the entire luminaire.
Yeah.
So it may be easier to qualify the light source itself.
Usually it is, yeah.
And you get a better number.
Yeah.
Question from Chris, and I think we've understood that already. Do the regulation apply to custom product or other low volume lamps?
Yes.
Yes. Yeah, well, one from Sergio that I think we have already answered, but it looks like B2B products are exempted from requirements to upload all data to April.
No, they're not exempt. No. So
Yeah,
I must say, so some of those questions, they are kind of similar. So, so a lot of B2B products, right? So, so if you're a light source that's not displayed in a retail store, for example, then some of but is directly B2B. So you supply to a luminaire manufacturer. Then some of the packaging requirements do not apply, right? Because there's no physical packaging that's visible to end users. So that is maybe some distinction to make, but all the other elements they apply as well as they do to lamps that you can buy in a store.
We have a bit of a deep dive question about portable lighting. Does temporary mains powered portable lighting as would be used on a construction site? I believe this participant is referring to rechargeable lamps that on a construction site fall under these regulations. I think there is a bit of a gray zone here. Is it considered a portable battery powered lamp, or is it considered a mains powered lamp?
Yeah, exactly. Yeah, I think that determines whether it's exempt or not.
Yeah. Yeah, I mean, there's no one stopping to use the portable lamp with the charger constantly connected, right?
Right.
But this is still a portable lamp.
Yeah.
This is arguable. John is wondering whether, from a commercial point of view, the consumer under this new scheme will see a drop in the energy rating from A++ rated to B at best, or even C or D, I believe. So new product will appear less efficient, and this may have an effect on sales. How do you propose this is managed? Well, maybe this is a question for a larger audience.
Yeah, I think that's something that that it is what it is, and there's so it's the scale has been inflated quite a bit, and certainly we have to do a reset. It's we'll have some job maybe to do explaining that, but in the end, I think it makes sense to have realistic really
I
nice.
think we need to do some education. I think the lighting industry representative bodies will have to push on the governments to make some educational advertisements to their country citizens, and also maybe the consumers organization will have to seize themselves about this topic and provide some guidance to the consumer. There's also not something that is not really written in the regulation, is whether the products with the two different labeling system will cohabit on the shelves of the retailers. This will probably cause a temporary confusion.
Yeah. So there's this transition period that we'll have to deal with. Should we move forward with the? I have a few more slides on the.
I will take more questions at the end.
A few minutes left. So I just wanted to close with some comments on how you can operate within this new context of these regulations, right? So how you design lighting systems, and as I mentioned, so an important part. So first of all, you have to meet performance requirements, and as I mentioned, most LEDs have no problem meeting those requirements. But as you also know and see here in this chart, there's a wide range of LED types, and if you're just looking at source efficiency, there's a lot of variation here, right? So some characteristics that can make it challenging is if you have very warm light sources. So, for example, you go to 2200 Kelvin because there's no CCT bonus in this power requirement. So if you go to higher drive conditions, so moderately high luminance, but not high enough to be eligible for this HLLS bonus, that's also challenging. Same for mains connected light sources. If you do some part of a driver in your light source, but not all of it, you're not eligible for the mains light source bonus. And so those kind of characteristics can make it challenging. So in general, I think the strategy is that you want to partition your system in a way that you can utilize the bonuses that were designed for your application, right? That are available there. And there are some other strategies too. Like if you want to do this very warm light thing, you can integrate it together with other colors in a color tunable light source, right? So be it a feature of the light source rather than making a single color, a single CCT light source, just a very warm light CCT. So those are good strategies to keep in mind when you design your system. Just a quick example: if you want to do a human-centric lighting module, so typical design goals are you have a tunable CCT with high color fidelity. You want to be able to deliver efficiently melanopic illuminance. And you want the highest possible energy efficiency class in these regulations, right? So you can look at comparing different LED types. So a fixed CCT LED at 4000 Kelvin, 80 CRI can get you to efficiency class B. But if you, as soon as you start to add tuning, so CCT tuning, and you want higher fidelity, then you're going to decrease in efficiency class. But so then you see that for this specific application, something like a Luxion Fusion can provide very good performance here, where you have high delivery of melanopic efficiency, of melanopic illuminance. So very efficient. You have high color fidelity, and you still get an energy efficiency class C, right? Which if you compare to some other products, so you can also get the high, an even higher color fidelity with these full spectrum LEDs, but due to their construction, including violet LEDs and multiple phosphors, where you have like phosphor interaction losses, you get lower efficiency, therefore lower energy efficiency class, and also lower delivery of melanopic illuminance. So it's really important to kind of see what are the important design criteria for your application, and then see, okay, what's the best I can do in terms of energy efficiency class. And basically, you have two options as a system integrator. If you can use a qualified light source, either standard or custom. So looking at our products, we have these standard matrix products and COB products, but we can also make custom products for you. And so by using these products as a containing product manufacturer, all you need to do is identify which light source you're using, and then provide instructions for removal and replacement. So this is really a good choice for a lot of systems designs. But there will be cases where you will it may be preferable to design and qualify your own light source, right? So then when you do that, then be ready to meet these requirements by yourself. You have to fulfill light source supplier obligations. So you also have to do energy labeling. You have to upload and maintain information in EPREL. You have to issue a declaration of conformity. You have to do CE marking. So all of that is involved, but it may be preferred for some cases where you have like very integrated light sources or customized light sources. So if you go the first route, then what you can expect from your light source supplier, from your LED supplier, is generally a performance benefit, because LED manufacturers have very high control over distributions, and can have LED data available that allows them to make very narrow distributions at light source level, which help you declare a higher performance, right? If you can narrow the distribution. And they can, they can take care of the information compliance. So the marking, so you will see some changes probably in marking on light source products, because we per these regulations, and you'll see information uploaded in EPREL as well. So when you decide to go the second option, that is you build and design and qualify your own light source, then your LED manufacturer can also support you mostly with more LED data. So since you need to you need to declare information of your light source for a lot of parameters, there's a lot of information you need, and most of that will flow from the LED itself. So you'll need to know flux and voltage for your specific operating conditions, the same with color. And so some of those metrics you might not find in data sheets today. So you'll expect to get more information from your LED supplier, including, for example, étendue factor for high luminance light sources, lumen maintenance factor, survival factor, in line with these eco-design lifetime requirements. Etc. So a lot more information to help you qualify your own light source. And it's very important here to have good design support in this phase, so that you can really optimize your light source design for the eco-design requirements. So for example, at Lumileds, we have already started implementing some of this in our online design tools. So now if you go to the system calculator and you enter your a system design, what you'll see already is that does it meet the power requirements? What's the energy efficiency class of this particular simulation that you're running? So you'll see all of that coming to our online design tools. Okay, so in summary, I hope I've shown you some of the impacts that these two regulations will have on the EU lighting market and on your lighting designs. So most importantly, these regulations move down in scope to a lower system level, which has quite a lot of impact. So it's important to be prepared for this transition, and we believe it really gives you a competitive advantage in the market if you are prepared. And we as a LED manufacturer can support your transition by providing a qualified light source as a turnkey solution, or alternatively, if you want to qualify your own light source, we can also support that by providing LED data and design support. So I'll stop here. I thank you for your attention, and I'll turn it back to you, Francois.
Thank you, Wouter, for the great spoiler. Thank you all for attending today's webcast. We hope it has been valuable to you. As Wouter mentioned, we are ready to assist you with the transition towards the upcoming regulation. And we invite you to contact your Lumileds or future representative should you wish to discuss your next design in more detail. We wish you a good weekend. Stay tuned and take care. Goodbye.